So what if my original function was a quadratic function? In this case here, x squared minus x minus 6. Well, my original function, I really should know where the vertex of this is. So I'm going to write this in the vertex form. I can find the vertex. P is going to be negative b over 2a. Okay, so my vertex is going to be a positive 1/2. Okay, so I'm just going to put that in here, positive 1/2. Okay, when x is positive 1/2, I'm going to end up with 1/4 minus 1/2, that's negative 1/4, minus 6, which is negative, that's going to be negative 6.25, and then the absolute value is going to be positive 6.25. Okay, so I'm going to have that coordinate. Now, really, I kind of want to know the zeros, so I really need to factor this. So, and the reason why I want to know the zeros is because the zeros indicate the point of transition between the original graph and the flipped graph. Okay, so when I factor this, I can find my zeros. My zeros are going to be, it's going to be minus 3, then x plus 2. So I can see that my zeros are going to be at positive 3. I'm going to write positive 3 and negative 2. And those are going to give me 0 coordinates. So I'm going to draw those in. So negative 2, 0, positive 3, 0, and the vertex, and this is a vertex that's already been flipped, it's going to be at 6.25 right there. Okay, so my original parabola, I'm just going to do this in red. Maybe I'll put in a couple extra points here. So when x is 4, I'm going to get 16 minus 10, that's 6. So x is 4, I'm going to get y is 6. Okay, and when x is negative 3, we'll get the same thing. X is negative 3, I'm going to end up with 9 minus 9, so that's going to be, is that negative 3? No, 9 plus 2, sorry, plus 3 minus 6, that's going to be positive 6 as well. Okay, and it should be because it's symmetrical. Okay, so it's going to be a point there. So this is my original graph. It's going to go through like that. And I'm just going to draw in my, just going to draw it in as a dotted line here. So that's what the original graph would have looked like. Okay, but what's going to happen to all these points that were originally below the y-axis? When I apply the absolute value, that point here gets flipped up to there. So what ends up happening then is all the negative coordinates are going to be flipped up like this. Oops, so that's going to be at negative 1/2. So right about there. So it's going to be flipped upside down like that. So there's my absolute value graph. And so the absolute value relies on knowing where the boundaries are. So what's the most important points to consider is when the y values are equal to 0. When the inside it's when the inside of the absolute value is 0. Okay, because that represents the boundary. The other good references to use, we should really use a vertex. Okay, the vertex of a quadratic is very important. Okay, so we get the zeros, that marks the boundaries when we're going to fold the graph. The vertex helps us identify where that graph's going to be. It's good to know where the original vertex is as well. And we're able to draw the function much better that way. So the last part here, and this is a little bit more advanced, and some of you may or may not have done this, but we're going to write this as a piecewise function then. So my original f of x, okay, so what does this graph look like? Well, for certain positive domains, nothing changes. It just looks like a regular parabola. Okay, and it's just going to be, maybe I'll do this in red because that's my original red graph. Okay, when the original y coordinates are positive, nothing changes. It just behaves like x squared minus x minus 6 parabola. But what's the domain of that? The domain is when x is less than, well, the boundary point is when x is negative 2. So I'm going to say less than or equal to negative 2, or the other boundary point is x equals 3, when x is greater than or equal to, so it's not negative 3, but positive 3. So that piece is going to be the outside pieces. The inside piece is the negative part, the part that got flipped upside down. And that's going to look like this. We're just going to take that original parabola. Since the y values are negative, we're just going to put a negative on the outside to make it positive. And the domain of that is going to be in between. Okay, so it's going to be less than 3, but greater than negative 2. So this is a domain of the negative part of the function, and that's the part in the middle. The outside parts is a positive part, which didn't get flipped around, and that's from less than negative 2 or greater than 3. So this is what it would look like as a piecewise function.